Estimados participantes, muy buenas tardes. Mi nombre es Leopoldo Zulueta, copresidente del Círculo de Estudios VDC, y hoy, junto con mi compañera Diana Gómez, tenemos el honor de ser los maestros de ceremonia. Les damos la más cordial bienvenida al tercer día de este tercer Congreso Internacional VDC. En esta fecha se desarrollará el eje temático VDC en el ecosistema público, privado y académico, donde contaremos con 4 ponentes internacionales de lujo: el doctor Martin Fisher, la profesora Nora Dainton, el profesor Lauri Koskela y la candidata a doctorado Tulika Mahmudar. Adicionalmente, quisiera comentarles que, así como en las fechas anteriores, se contará con traducción simultánea por si desean escuchar la ponencia en inglés o en español respectivamente. Solo deben activar la opción de intérprete ubicada en la parte inferior. Además, a lo largo de la ponencia pueden dejar sus consultas dirigidas a los ponentes en la casilla de preguntas y respuestas del Zoom, que se encuentra también en la parte inferior. Ahora, invitamos al doctor Alexandre Almeida, director del Instituto de Investigación Científica de la Universidad de Lima, coordinador del Programa Internacional VDC y del Congreso Internacional VDC, desarrollados ambos en coordinación con el Center for Integrated Facility Engineering y la Universidad de Stanford. Adelante, ingeniero Almeida.
Muchas gracias, Leopoldo, por la introducción y buenas tardes con todos. Antes de empezar nuestro tercer y último día del Congreso Internacional VDC, me gustaría hacer un pequeño resumen sobre el día de ayer, donde desarrollamos el segundo eje temático, VDC en la construcción disruptiva, en el cual conversamos sobre el aporte de la metodología VDC en las nuevas tendencias de la construcción en apoyo de los avances tecnológicos aplicados en la industria. Los primeros ponentes de la noche fueron los ingenieros Raúl Israguiri, jefe corporativo de innovación en COSAP, y el ingeniero Omar Alfaro, gerente de proyectos en COSAP. Ellos nos comentaron cómo COSAP adaptó la reingeniería de procesos dentro de sus proyectos e incorporó VDC para pasar de ser um objetivo desejado a um objetivo necessário a curto prazo dentro de sua organização. Sucessivamente, o engenheiro Roberto Arbulu, quem é vice-presidente executivo de serviços técnicos em Strategic Project Solutions e membro e instrutor em gestão de la produção de projetos em el Project Production Institute, nos comentou acerca da visão de la produção inteligente para la entrega de los proyectos de capital y la relación que tiene esta producción con las tecnologías digitales y la gestión de la data. Finalmente, comentó cómo las empresas y organizaciones de la industria pueden implementar la producción inteligente en sus actuales proyectos. Seguimos las presentaciones con Ashwin, quien es doctor en Filosofía y Ciencias de la Computación en la Universidad de Stanford. Nos explicó el día de ayer cómo los gemelos digitales se relacionan con la metodología VDC y a su vez cómo se aplica a la realidad actual de la industria de la construcción, combinando la tecnología dentro de sus procesos. Finalmente, Letícia Zanotti, actualmente es asistente de enseñanza para las clases de gestión de fabricación y construcción, robótica de construcción y construcción industrializada en la Universidad de Stanford, nos comentó acerca del uso de la robótica en la construcción y cómo esta práctica está transformando la industria. Finalmente nos compartió ejemplos de robots que están siendo utilizados actualmente para cambiar y optimizar los procesos en la industria de la construcción. Luego de las ponencias tuvimos el agrado también de escuchar las experiencias de certificados del programa VDC en colaboración con el SAIF y con Stanford Center for Professional Development, quienes nos comentaron de sus proyectos de implementación de la metodología VDC. Contamos con la experiencia de la arquitecta Mónica Vergara, jefe de prácticas y asistente de investigación en la Universidad de Lima, quien nos explicó sobre cómo se implementó VDC en la investigación y el desarrollo de un modelo de inteligencia artificial para la supervisión y monitoreo remoto de obras. El ingeniero Alejandro Palpan, coordinador de proyectos de ingeniería de detalle y supervisor de I+D en TSC Innovation, nos comentou sobre a gestão de projetos de infraestrutura, especificamente a construção de puentes, utilizando a metodologia VDC. Também nos explicou como uma visão general de como se gestionam, desenvolvem e que tecnologias se utilizam atualmente para este tipo de projeto, basando-se em um caso de aplicação como o exemplo do puente óvulo monitor executado em Surco, Lima. Esta noite, senhores, conversaremos sobre o último eje temático, VDC em ecossistema público, privado e acadêmico, em lo qual conversaremos sobre a versatilidade da aplicação e adaptação da metodologia VDC em projetos de diversos sectores da indústria e em las etapas de los mismos, que nos permite conseguir melhores resultados em prazos menores a lo largo de todo o processo de elaboração. Muitas graças novamente com todos, bem-vindos e que desfrutem nosso terceiro e último dia. Muitas graças e adelante, Leopoldo.
Muchas gracias, ingeniero Almeida. Buenas tardes con todos nuevamente. Para dar inicio al programa, les recordamos que se contará con traducción simultánea por si desean escuchar la ponencia en español. Para ello, deberán activar la opción de intérprete ubicada en la pestaña inferior. Asimismo, les recordamos que las preguntas formuladas serán respondidas al finalizar la presentación del ponente. Ahora invitamos al doctor en Ingeniería Civil por la Universidad de Stanford, Martin Fisher. Él es ingeniero civil por Swiss Federal Institute of Technology, profesor de Ingeniería Civil, Ambiental e Informática y director del Center for Integrated Facility Engineering de la Universidad de Stanford. Es miembro superior del Precourt Institute for Energy y coordinador del Building Energy Efficiency Research en la misma casa de estudios. Ha publicado más de 100 artículos en revistas referidas y capítulos de libros. Durante su trayectoria profesional ha sido premiado por la National Science Foundation. Fue considerado dentro de los 25 mejores columnistas por la Engineering News Record y ganó el premio al mejor artículo de informática e ingeniería civil para AC Journal. Fue elegido también miembro extranjero honorario por la Royal Swedish Academy of Engineering Science. Go ahead, Dr. Fisher.
Thank you, Leopoldo, and thank you, Alexandre, for the introduction and also for having, again, this Congress. And I also thank the speakers from Europe for still being up, or up again. Okay, so as I was thinking about the theme of this session, I wanted to, well, focus on something a little bit different than I have usually talked about when we talk about VDC or when I present about VDC, which is my role as a university researcher. And at a place like Stanford, we are expected to create new methods that allow better engineering, better construction, better use, operation of buildings and infrastructure and so on. So I will focus my talk here on using VDC as a framework for collaborative industry academia research. And I'll illustrate that with 3 examples of research projects. And hopefully we can use that as an inspiration and also then as a basis for conversation and discussion. So yeah, you've already heard enough about me, so I will jump on to right away, dive into our first industry academia research collaboration experience. And as you will see, the first 2 examples, they really precede the formalization of VDC. But in fact, what I've realized thinking about this presentation, we had already the VDC mindset, and these experience helped us formalize VDC in the early 2000s. So I still remember the day when I was in the office at SciFi as an assistant professor, and this senior vice president for one of the major construction companies in the area at the time, Jack Ritter, walked into the office and said, we have just gotten the contract for a really, really exciting project, the renovation and extension of the only public hospital in San Mateo County, just very close to our campus, about 20 kilometers away. over 6 years. And this was a period when there was really not a lot of construction work. So this was really a fantastic opportunity for this company. And but he said, I have a problem because the hospital has to be fully operational while we are building. The client needs to see the interaction between the construction schedule and the construction activities, extension and renovation, and the operation of the hospital, and need to understand that or make sure that the construction operations and construction activities do not affect the operation of the hospital too badly. But we cannot show that with the existing tools and methods. We've created 2D drawings after 2D drawings every month showing what's happening. And the owner just keeps saying, sorry, I don't understand. I am not going to give you the go ahead. Then he said, surely you, the researchers at SciFi, can help us. And after reflecting a little bit on that, not for too long, a couple of minutes, we thought that this could be interesting to try this emerging method at the time, which eventually became known as 4D model. We had not built one ourselves. We had seen it being used mostly by Bechtel on power on industrial projects, but we had not seen it used in sort of building projects. So we were curious as researchers to study the effort to create and maintain a 4D model and to measure its impact on the project. And so the key question, for example, there were many, but I'm just illustrating this, and you can see the sort of the level of detail of the 3D model, and then eventually also 4D model. One key question the hospital wanted to answer conclusively is there a path from any department in the health center to any other department within the center at all times? Because they didn't want to have to put the patients, onto a movable bed and wheel it out on the street around the corner and back in on the other side of the block. So, and this was indeed very difficult to show over the course of the full renovation of this hospital. And within really literally a couple months of starting development on the 3D model, of course, as you can imagine, at the time there was no 3D model. We had to build a 3D model. We had to connect it to the schedule. We had to align all of that. Very soon after starting to build this 4D model, we realized that actually the construction schedule indeed had been pretty good in considering this requirement, but that there were actually also a few weeks when there was not a path from every department in the hospital to every other part. And so that led to some adjustments in the construction schedule and in the temporary structures. And so what we found, even though at the time the technology was really, really very expensive in terms of hardware, special hardware needed, and software, and much, much more than it costs today, even in actual dollars, never mind the adjusted dollars, the whole research effort was actually paid back with the 3D coordination of the central utilities plant, which is the structure kind of in the back here. So a very relatively small part of the whole project. But we found so many issues there that that effort already paid for itself just on that. And so then the general contractor was really quite happy. But if I summarize this in the VDC framework, right, the hospital operations needed to go on fully during renovation and extension, like that constraint in terms of access from every department to every other department within the hospital. Also, of course, from a contractor perspective, from a project objective, they wanted to complete the work on schedule and without delays due to interference with hospital operations. So they wanted to keep being productive as builders, which they wouldn't have been able to do because if there was interferences with the hospital operation. So some of the methods they deployed, we had weekly ICE sessions with the construction team and monthly ICE sessions with the client to review the construction schedule. And we also had, so that with the goal that we wanted to complete all of the construction, hospital operations, and appearance checks in 3 months. I think we managed to do it in 2.5, if I remember right. On the BIM side, we needed a 4D model with construction, with of course the construction activities, including temporary structures at a level that allowed connection with the hospital activities. And we wanted to resolve 100% of the interferences we found each week. And in terms of the process, we needed, as I mentioned already, construction schedule at the level of detail to understand this relationship with hospital operations. And we wanted to make it so that we could update the 3D 4D model every week with what was discussed in that I session. So you could say, this project really started, if you reflect on it, with a challenge, with an overall concern that hospital operations would be affected by construction and vice versa, and with corresponding budget schedule impact on both sides. Then we saw the opportunity to deploy a new technology, but then very quickly realized that we needed to adjust the workflows, and including in the workflow, in our case at the time, weekly I sessions with the project leadership team and monthly I sessions with the client. So we realized very quickly that these elements had to go hand in hand to make the technology useful and to bring value to the project as quickly as possible. So even though at the time we didn't put things into VDC framework, in a way, we actually quite quickly gravitated to something like it. A few years later, we had an opportunity to do our first, what I would say, our first IPD project. And you will see now with technology and so advancing a little bit, and the scale of the project being a little bit bigger, getting closer to the kind of technology we have today, and but also learning at the same time the organizational impact. So this was a pilot plant project, a biotech pilot plant project for a startup. And from the industry perspective, project manager for the general contractor, Melody Spradlin, wanted to break into the biotech market and needed a reference project. And so she approached this client and said, you need to build this pilot plant. I think a traditional design construct process will overwhelm you because you don't have the organization to manage that. But we would like to do some R&D on our side on this project so that we match culturally with your R&D culture. And the client was actually thought, yeah, that's a very good point, and proceeded with this team. And the team consisted was really, I would say, an IPD team, even though we didn't have the term at the time, because it included an integrated architectural engineering company, the general contractor, mechanical, electrical, and piping contractor. And we were curious to see how practical would it be to support such a team with a 3D 4D model for design and construction planning and coordination, a quantity takeoff or estimating, and fabrication from the 3D model of mechanical and piping at the time. And from a research side, yeah, we were curious, is this technically and organizationally feasible? What is the effort? And what is the impact of having such an integrated model today? We might call it 5D model in some cases, on this project team. So just to illustrate what we did, for example, we coordinated the construction work at the daily level with 4D models, and also were able to prefabricate about 30% of the piping and the mechanical pieces from the 3D model. Maybe for 1997 was not so bad. We did the cost estimate. We found, for example, just a few anecdotes here, that the researcher, Cheryl, who is now a professor at the University of British Columbia in Vancouver, the researcher, she had 2 years of practical experience before becoming a researcher. She was actually able to do a cost estimate of equal quality based on the quantity takeoff from the 3D model in half the time than the experienced estimator of the general contractor. And also that cost estimate was actually useful, much more useful in design when design changes had to be considered. So just a few anecdotes. And again, as I reflected in preparing for this talk about the application of the VDC framework, of course, for the startup, it was really, really critical that they could start to use the pilot plant on schedule. Because you could imagine their investment, everything is tied to scaling up their technology. So the project team had to complete the construction on budget and schedule. And here they also had this objective of learning about 5D modeling. Not surprisingly, we wanted to resolve all the conflicts, and they were managed at a much more detailed level, right, in terms of the 3D coordination, but also the daily construction coordination. We wanted to manage them every week, and basically that's where you see here the controllable factors being described as weekly I sessions with the 4D model with detailed construction activity at the daily level, integrating the GC and the MEP schedules. Similarly, I mean, as you could hear, the starting point was maybe slightly different here in terms of aligning the cultures of the project team. But then very quickly, we really integrated the organization, as you could see with the architect, engineer, general contractor, MEP contractor, supported by this 5D model, and but also creating this 5D model, where really then the major process changes came in terms of these weekly coordination session. You know, in 1997, that was not typically done, for example. And as a result, the project was completed on budget, on schedule, included what the client wanted. And the two teams were extremely friendly at the end of the project. I think everybody had also a lot of fun. The client did comment that they had to do more decision-making during the early phases of project than they had sometimes capacity to do, because, right, as you have experienced probably on your projects, a lot more information was available digitally and had to be dealt with and conclusively by all the parties. And the third example I want to share is more recent. Our first full, what I would say, full is always a tricky word, but full optimization project, were done with Filippo Vanali and many other parties that you will see in a minute. This was an office building in California, included a developer, general contractor, structural engineer, steel fabricator, and steel erector. And it really was motivated by Brian Grass, the project executive for this project for DPR. And he was wondering, after seeing a presentation, and I'll show you glimpses of that, on optimization of structural design and automation and optimization, whether we could create faster and full feedback on architectural design. So, you know, these design cycles are just incredibly slow. And then we end up with a structure that's, I'm not so sure, really optimal. And we were also curious to really push the limits of optimizing structural systems and understand whether that's worthwhile, what the impact of that is. So here, again, from the research side, we wanted to study the technical and organizational feasibility, effort and impact of an optimal composite steel concrete structural design. And I mean, as you can already maybe imagine, there is quite many issues. We had to get access to the structural engineer and the analytical model they had done in great detail. We had to get access to all the fabrication and construction and erection cost data, because otherwise we would be limited to just optimizing for the steel weight, for example. We had to get access to, you know, the development constraints and the architectural objectives and so forth. But I'll come back to that. So this, the Filippo you see on the left was really the main researcher, and then Brian on the right really our key industry partner, also supported by a tool from DPR that many of you know. And then on the academic side, it was me and Eduardo, my colleague, who is a structural engineering, design, construction, integration expert, and also Ram Rajagopal, who is really a data science expert. But the genesis of this project was a presentation that Brian saw in an executive program that we gave, talking about the future of engineering and construction, where we talked about multidisciplinary design optimization that we had been able to do with a major theme park company, where the challenge was always in those projects the design of the so-called secondary steel. When you build a mountain, like this theme park operator does many times, you right, the designers still create the facade, so to speak, of the mountain, the surface of the mountain. But if you want to open the mountain on time, then you need to order the primary steel quite early, before you have finished the design of the facade, the face of the mountain. And so as a result, the secondary steel connecting the face of the mountain with the primary steel is always on the critical path. There's always never enough time, and it ends up you end up spending typically much more money on the secondary steel because you just have to make it happen. So we this theme park operator was wondering whether this structural steel design for the secondary steel couldn't be automated. And so Filippo was working on that project as a summer intern, and it was really actually quite surprising, amazing to see the results in terms of, in this case, the weight reduction we were able to achieve with an optimal steel design. It looks kind of similar if you look on the left and the right, but in fact, right, as you saw, it's 42% lighter and has 47% fewer unique connection details. So significantly better to erect also. So, but this was relatively limited optimization problem focused just on a secondary steel. We were wondering what it would be like to take this to a whole building, or the structural design of a whole building with all the aspects. Is it feasible computationally? Can we get the cost data? Is the problem size just too big? Can we break up the problem in ways in which makes it feasible and also useful in the industry? So the building on the left is not exactly the building. The building we looked at is larger and more complex, but you can imagine for confidentiality reasons we can't totally show the actual building. But it's a building in an office building, major office building, 20-30,000 square meters that you would find in an office area, in a downtown area in a major city here on the West Coast. And we actually were able to work with two buildings, one building where we could learn how to do the optimization, and the second one where we could test it. So I'm going to show the results of the test. But the goal was to optimize the steel composite design of the steel and concrete structure, including member sizing, connection detailing, constructability, material cost, erection cost, fabrication cost, and of course, the structural safety, the code compliance, all of that is a given, could not be violated. So this is what we are trying to show here, to have this, what I would say, full structural steel optimization. So we were curious, is this feasible? And we were able to find a way to make it feasible. And then what is the effect of having this integration of cost data and then the ability to optimize. And so here is the comparison of the structure that was designed by the very, very good structural engineer in today's traditional process, and what you could get if you deployed this optimization method. And you can see that the optimization method leads to a structure that's 10% cheaper. And you can also see that it was done in an hour versus several weeks for a typical design version. And it's interesting also to see that all of the savings pretty much coming from the detailing side of things. So this was really a bit of a wake-up call for me to reflect on what the major structural steel design you can see is essentially the same, the steel weight. And that's decided fairly early in the design process. But then by that, you're locking in particular ways of having to detail the structure. And by the time you get to those details, you can no longer go back to the main structure to change it. But here, because we can consider all of these aspects concurrently, we can vary the primary steel design so that it becomes much more constructible, as you can see, and that really is where the 10% savings are coming from. So we found, that we were able to lower the cost of the steel structure, dramatically speed up the design, provide actually a very safe structure, and really being able to know that we have a very safe structure because we can validate, verify that everything has been checked. So it becomes auditable. And you could imagine now that you could explore all kinds of scenarios if you can get feedback in an hour on the optimal structural design. So in terms of the VDC framework, we, again, you could say, well, focus a bit of a technology-driven project where we have the, focus on developing this optimization method, which included, for example, automatic transfer of the architectural BIM to the structural connection with the structural BIM into the optimization method, which is one thing I posted there. But very quickly, we realized that we have to learn a lot about the process, that it is in terms of the production process and the cost, but also in terms of the effect this has on the design process and the collaboration between the developer, the structural engineer, general contractor, steel companies, steel erection and fabrication companies. And that it affected, of course, as you can imagine, very much the work they did in terms of the workflow, the process, the aspects they managed, and then the coordination sessions to align the design, production, and cost information, for example, that were needed. So we had to do things that they normally don't do, but many things that they normally do fall by the wayside. You no longer have to do because now they are automated in the computer. And so we're able to show that we can minimize the cost of the structure, so allow the client, the developer in this case, to put more money where the customer actually sees it. In the interest of time, I'll jump over these. We have had the privilege, pleasure to work with many industry applications over the 30+ years of SciFi, very much in the spirit. And I found really these two statements as guiding our research. The automated execution of processes changes everything. That's the business perspective, and that's what we see, right? Structural design in an hour is a very different story than structural design in a few weeks. But that connects very well with the scientific perspective, which is, for me, very well expressed by this quote from Donald Knuth, a computer scientist at Stanford. Basically says, trying to automate something teaches us what we know about the problem and what we don't know. And when we know something, when we know enough about it, we can automate it. When we don't know enough about it, then it stays an art, something human judgment has to deal with. And so from a research perspective, this becomes basically the way to understand the limits of today's knowledge and to extend it. But then the VDC framework is super helpful to connect, right, the research, the academic, and the industry perspective. Because as you could see, we could not do this research just in the ivory tower of academia. We have to collaborate with industry. And by necessity, then you're very quickly talking about what is the computer doing and what are the humans doing. So you immediately have to focus on the ICE and the BIM part. And BIM understood quite broadly in terms of creating useful information and using useful information. But that by itself, right, would not give us very defendable research results. We have to understand the objective. What is it that we're trying to achieve? What is it that we cannot achieve today? What is it that we would like to achieve? And naturally, we then spend a lot of time. So that's kind of where we start. But then actually, we have to spend a lot of time in the production on the research side and on the industry side in production management, to make the research happen, to have it have useful results, to contrast today's methods with the methods that are enabled by the research, and so forth. So I found the VDC framework extremely helpful to guide academic industry collaboration to advance the engineering, management, construction, and building operations methods. So thank you for allowing me to talk about this, and I hope many of you will use the VDC framework to advance our methods, because it's absolutely necessary, as you know, to achieve more sustainable, higher performing projects more reliably and more often.
Thank you very much, Dr. Fisher, for sharing some of your industry academic experiences and insights in VDC and IPD. We have the following questions for you. What advice would you give to academic institutions so they can develop lasting and profitable relationships with the construction industry?
Yeah, you have to spend some time meeting the industry. You have to, so we go into the trenches with the companies, but typically only when we see that there is really a desire to go on, I mean, to really push the envelope as well. But then I found you have to challenge yourself and actually roll up your sleeves and help them on their projects. And I found when you do that for a while, then they start helping you. When you just show up as a researcher and say, I want to research this, and I'm not really that interested in your problems and what you have to deal with, I have not had much success. But this is not, I find, the typical way of working. Many of my students, you will hear from one soon, are a little bit surprised by that, although I think they know that. Because I've also learned and seen that many students are students because that has been the easy way for them. As hard as doing a PhD is, they are very comfortable studying, and maybe less comfortable going onto a construction site and dealing with all kinds of different people there and dealing with the problems there. So I think, but if we want to do conceptually strong and practically relevant research, then we have to find a way of functioning in both of those universes. So that's what I've learned, that we have to meet the industry, and once they see that we care about their work, we can start to challenge them, and then we can have a relationship that really advances our research and our methods.
Thank you so much. Here is a second question. Do you consider that it's important to implement the VDC methodology in a civil engineering undergraduate and/or graduate program? How important do you consider it to be?
So for me, I cannot help but look at the world with the VDC lens. And I had this similar question from a very experienced construction person who asked me, like at what, a little bit different question, but in a way similar. What size project would you recommend VDC should be used? And then I said, well, any project that benefits from better resource utilization, from clear definition of goals, from good information, from clear processes, from the timely collaboration of professionals, that should use VDC. But if you think your project is better because it has information that's less good, unclear goals, misaligned processes, and little collaboration between disciplines, you don't need VDC, it's okay. And of course, the people, I realize it's a little bit of a almost facetious answer, but I couldn't help it, because on every project, right, you should have clear goals, objectives. Otherwise, how do you know the work was good or bad? It was impactful or not? You should leverage the knowledge of the people on a project. You should have good information, and you should have aligned, good and aligned processes. So if you can really tell me that that's not necessary on every project to make it good, okay, then you don't need VDC, but otherwise you do.
Okay, thank you so much. And the last question is, could you give us an estimate of how much does it cost to implement VDC on construction projects and academic institutions?
So in all the cases, so the long list of projects I showed you, the research paid for itself, which not everybody always agrees with me that this should be a goal, but this was always my goal, that I didn't want to do research where there was basically no expectation, where there was basically, let's just find out what happens. I wanted to have an expectation that there is value provided on the project so that I could say these methods are actually useful, at least on one project. I realize it's, academically tough to really generalize. In industry, that's a little bit easier. So I've always wanted to have the expectation of value right away or fairly soon in the frame of the duration of the project. And so I would say, yeah, I mean, somebody had to believe that, somebody had to put the budget there to get started. But at the end of the project, it was always at least cost neutral, if not actually savings. So yeah, that's my experience. But this is also a longer conversation. I realize that, but this is my experience.
Okay, pretty interesting. And once again, we appreciate your participation, and we move on to the next speaker.
Buenas noches con todos. Soy Ana Gómez, coordinadora del Círculo de Estudios VDC, y seré la segunda maestra de ceremonia de este día. Para la siguiente exposición, les recordamos que se contará con traducción simultánea por si desean escuchar la ponencia en español. Pueden activar la opción de intérprete ubicada en la pestaña inferior de sus pantallas. Asimismo, les recordamos que las preguntas formuladas serán respondidas al finalizar la presentación del ponente. Ahora, es momento de invitar a la ingeniera Nora Deinton. La profesora Deinton es directora del programa de maestría en Diseño y Construcción Virtual en la Escuela de Arquitectura, Ingeniería Civil y Geomática de la Universidad de Ciencias Aplicadas del Noroeste de Suiza. Hasta su nombramiento como profesora a principios del año 2021, fue profesora en el Instituto de Diseño Industrial durante más de 10 años e implementó proyectos en los campos de diseño de productos, gráficos y fotografía en su propio estudio de diseño. Además, tiene una maestría en artes en diseño y realiza investigaciones sobre temas de didáctica en la educación superior. La exploración de potencialidades, tanto en la enseñanza como en el diseño de procesos y lugares, son temas recurrentes en su obra. Thanks for your participation, and go ahead, Professor Dayton.
Thank you very much. I shall jump right into my presentation. Good, thanks for introducing me. As you said, my name is Nora Deinton, and my presentation today with the title Driving the Future Development of the Construction Industry is, as you all know, located in the third thematic X, and there I am focusing on an academic ecosystem. I will start my presentation with a question, or open it with a question, simply asking why should anybody specialize a master's degree just in VDC? Why should that be necessary? I think Martin Fischer already answered that widely in his talk, but I have as an answer to that, because we really do need skilled professionals to drive the future development of the construction industry. And I'm looking forward to now, with my presentation, give you insight into a master's degree program in virtual design and construction, and to elaborate on how our students become those skilled professionals we need for the industry, and so they can drive the future development. I have settled on content where I will very briefly introduce the university and the institute I'm based at to give you a bit of background. And then I shall give you insights into this master's program, which I'd like to show you the main topics we have and how they are connected to the VDC framework, why that is so important for us. Also, I will give insight into the structure and educational concept we have for this degree, and I shall share the experience we have made so far with our students and industry reactions we got for this program. Yeah, and at the end, I'll come back to the title of this presentation. Good. So the University of Applied Sciences, Arts, Northwest Switzerland is one of Switzerland's leading universities, also one of the biggest. There's basically two very big applied universities which share first space, more or less. We are actively involved in teaching, research, continuing education, and also consultancy. And the university offers a broad range of degree programs, an innovative application-oriented research, and we have a global network. The FNW is a diversified educational institution and a sought-after industry partner. So, and within that university, there's the School of Civil Engineering and Geomatics, and within that is the Institute of Virtual Design and Construction, where I am based. It's one of the bigger institutes in the School of Architecture, Civil Engineering and Geomatics, and we have an interdisciplinary team with backgrounds in engineering, architecture, construction, and we are focusing on organization, information modeling and management, and also on collaboration and process design. We do have applied research and development. We have a continuing professional development program, which is in a CAS or a MAS, and also, which you might know, is the VDC certification program, which is also part of our program. And relatively new, I will explain that, is the master's degree program that the further presentation will evolve around. Good. I start here with this graphic of the main topics we have in this master's program. It's information modeling and management, and collaboration and process design. So it is an interdisciplinary program that offers theoretical and practical examination of digital planning, construction, and building management. And it combines content on information modeling and management with aspects of integrated cooperation and process design. So in short, we basically offer a socio-technical program where we deem technical skills as important as social ones. So who are our students? Broadly speaking, they are ordering, planning, and executing stakeholders from the construction industry. You see here on the slide that might be somebody with a background in facility management or architecture, HVAC, civil engineering, other engineering, geomatics. Our students come with a background. They do a bachelor in a certain field, and we offer them with this program that they can elaborate on this one special theme. So yeah, we provide the students with qualified knowledge and skills in the field of VDC. And we have this little image with a backpacker who's got the VDC backpack, because we say he or she can bring back into the construction industry these specialized skills in order to drive innovative solutions which meet client and project objectives. What is important to us in this program that individual profiles are being maintained and that each student can build on their own specialization. So, for example, an architect or an engineer will still be an engineer when they've done the master's degree with us, but one with specialized skills that they then can use in their field. Here I brought you a first picture, a picture of our students, our first class on a field trip in Oslo last spring. I will tell you a little bit about that field trip as well. And this is just to show or to give you faces to this graphic I have on the left side with the different stakeholders. Because the interdisciplinary composition in this study program is crucial to us, because students do not only benefit from each other's knowledge, they also get to actually work and develop projects with different professionals of the construction industry. And this is an experience that brings them close to target-orientated project setups like they should be in the real working environment. Good. So as next, I will make a connection to the VDC framework. I brought a graphic we use here. It's based on what Martin Fischer and John Kunz developed. I guess you all know this graphic in some way. It's slightly changed, not much. The alterations are mainly the colors, which I will explain what they mean. But what is important is the core principles, which are very much maintained. So we say we have a degree which is aligned with the VDC framework or the methodology of the VDC framework. And that means that digital planning, construction and management, which involves the use of digital building models in combination with suitable forms of organization and processes following objectives. So as a next, I bring this graphic with the puzzle. Again, I don't know if you noticed before, it's a puzzle. The puzzle kind of shows the understanding of this program that technical and social aspects are always interwoven in all aspects of a project in the building process. So yes, you can see, you can say it's very important that we develop tools, roughly technical for the area of building information modeling, and that is very, very technical. But the tool standing on itself is not going to get very far. So there's always also an aspect which looks at the processes and also on the social connection between that tool and the people using it, and mainly also the integral cooperation between different stakeholders of a project. So this interconnection in the puzzle is also shown with the colors in the graphic of the VDC framework, as I just explained, that you have combinations. And therefore, these two main topics in our study program are always interwoven also in projects. Further, we are very convinced in our project, in our program, that the integrated forms of collaboration that characterize VDC must already be applied to teaching in order to ensure the best possible education for students. So this reminds me a little bit of what Martin was showing us when he said he's taken the VDC framework for as an application for research. So I have this mirror image as the way we want to teach It's not just the actual subjectives that we teach, but the way we understand. And this, I want to show you a bit more what this could look like, or how we're trying to achieve this. So very roughly speaking, our program is divided in 3 module groups. What you see here in red is the subject modules. So there our students would learn a bit of programming, they would learn a bit of parametric design, they'd learned technical aspects. Also, they learn about project organization, about communication. So these are all subjects they're learning. It's roughly 1/3 of the time they invest in this study program goes on subjects. And then what you see in gray in the middle, the integration projects, which is almost 1/3 of this program, means that in their study, they do 4 of these projects. And yeah, I'll tell you a bit more about the integration projects. They offer the students a basis for integrating and deepening knowledge and competences that they have from these subject modules. And to give them a base which is always attached to the real world, to practice based, these integration projects are always together with partners from the industry and from the construction industry, and they offer problems they have, themes, anything that is interesting, obviously within the VDC framework. So it's also of interest for our study program. And those projects, the students then always work in interdisciplinary groups. So we make sure that an engineer and an architect and maybe somebody from facility management develop that project together, and again have this set up of mixing stakeholders. Within the projects, the students, by the way, can set their own focus. So they can say, I want to do more a technical-based project or more a process-orientated one. And so what is interesting about this, and is a main part of our concept, with these integration projects, we don't have the idea that all the students will leave with the same knowledge or will learn the same. It's more a focus that our students acquire the same way, the same mindset, matching the VDC framework, so they can develop a similar thinking and acting with their competencies. Because subjects or single methods, we can always pick up on the way, we can always build on what we have, but the culture and the mindset that drives the way we work for us is like the main framework, the main structure in this. So basically we have emphasis on project-based learning. We give plenty of opportunity to do individualized immersion, and yeah, integrated forms of collaboration are really key to what we want to achieve. A next element of our structure or of our educational concept I want to show you is we have a community of students and teaching staff. And this is really a core element, or is really important to us that it is understood that we are a community. So we tell everybody from the first day that we really work at eye level, because we all have an understanding that we learn from each other, that we benefit from each other, and that we can inspire each other. So obviously, I as a professor, I will bring some knowledge my students don't know, but I also know that they will bring knowledge to a class that I don't have. And this is this idea of a community learning from each other. And yeah, this our preferred mindset, I think, is also the mindset needed for the construction industry in order to, again, reach project and client objectives. So again, I'll come with this VDC framework also to elaborate on the parallels I want to do to this. You see in the center these three figurines in the VDC framework. Integrated concurrent engineering, or we also have broadened that with, just generally speaking, integral cooperation, working together. And what I've just said about the community or the working together and benefiting from each other's knowledge, I think is also a center part in this VDC framework. And yeah, we get further together than against each other, which I know in practice is easier said than done. But again, I think if we have specialized, trained people in the industry that have really learned this mindset, then I guess the success rate with these forms of cooperation will increase. So I explained how important the community for our program is. I would like to point out that this is also important for an educational concept. I don't know if you've ever heard of inverted or flipped classroom. Basically, inverted classroom says the learners get provided with out-of-class materials where they read, they study, they have videos for certain themes. And then when we meet as a class, then we really use that time for the discussion, for questioning, for sessions, because just one person speaking, you can do that online, offline, in your own time. So classical lectures rarely look like this picture, although it can be important, it can be helpful. This is, by the way, Martin Fischer speaking on the very first day of our program to our very first students. And so here, obviously, it was fit that they just sit and listen and then ask. But in our daily study program, it quite often looks like this, that as groups, we work together with various media. We've got people interacting and really benefiting from each other's knowledge. Yeah, and I guess once again with this VDC framework, the coming together is really important. And yeah, if I look at the ICE session and if I ask, is it better if in a large scale project, one person talks for 3 hours and then thinks that this is all the necessary bits, or you do an ICE session, or you have a big room where you really integrate what you learn from each other. I guess there's a better version of these two options. So in short, or to enhance the social competence and the interplay between individual and group is important for our study program. And we find a lot of that in the VDC framework. Now I'd like to come to the third part of my presentation. I'd like to show the experience industry reaction we have made. And here I'd like to start with just briefly, we've got 16 students that started in 21. In autumn 22, we will start with a similar sized group. And so far, we've got very positive feedback from the industry. We have future employees that are actually already seeking, that are already employing students before they have started. But also to show you where I've got this information from, that we've got a very positive feedback, I would like to give you 3 examples from our study program. So we have these integration projects, which I explained more or less how they work. We've done 6 different projects in the first year with partners from the industry. Our students have worked in interdisciplinary groups, and the partners, as told, have offered research themes from the building industry. The results that our students do, they have 10 weeks to develop the project. They get presented and they get challenged and commented by our partners. And one of our partners actually called it a success story, because they said for them it's very important what they learn from us, and also for our students, obviously, it's very important what they learn from our partners. The second example is the International Study Week in Oslo we've done. This is a fixed part of our program that we do one International Study Week. Oslo was one very good option to start off with. And this is about, we visit various construction sites, planning offices, universities, we exchange with stakeholders, and it's about insights and experience, and also exchange and opportunity to broaden our view and our network. Hans Tomsholm from Stadsbygg was a fantastic contact to open many doors and also to show us very interesting construction sites. We got to visit Snøhetta, had fantastic time doing TACT planning as a workshop, and obviously got a lot of interesting insight from the industry. All our partners there, we asked what they think about the program, what they think about the students. As well there, we met a lot of enthusiasm. And interesting was we asked our students to sum up after a week what they really take home from this week from Norway. And they said to plan together and invest in a culture of trust is very important. And it's also very important to use customer goals, project goals, and metrics for successful projects. And also often quoted something that Hans Thomas Holm said. Basically, he said, what you give is what you get. And this is also something that I think is very true for education in general, and for what we try to achieve with this study program. A third brief example before I run out of time. Open Master VDC, we decided at the end of the first year to give insight and share and reflect on all the emerging knowledge we have from this first year. We had a lot of guests, which with conversations, we showed, our professors talked about certain subjects, there was a little exhibition, and also our students presented their results again. And also here we had a lot of interested people from the industry coming along and saying, oh yeah, can we do the next project with you? So I really can say we get a lot of enthusiastic and positive feedback from the construction industry that says we do need people like that. So I'm coming to an end. I started with the question, why a specialized master's degree in VDC? I briefly answered with, we need skilled professionals to drive the future development of the construction industry. And as a last statement, I'd like to say that a university in general has the unique possibility to offer a protected environment where research and teaching mutually enhance one another, and where the shaping of vision has more space than in the working world. And in this environment, and with the Master of Science in Virtual Design and Construction, we provide a path, I think, to driving the future development of the construction industry. Thank you very much. And thanks for listening.
Okay, thank you, Nora. Thank you very much, Professor Dayton, for your presentation and for sharing with us the importance of VDC in the academic sector of the construction industry. We have the following questions for you. The first question is, what are the biggest change you made to your program, comparing the first edition with the current one, taking into consideration continuous improvement?
Mm-hmm. Yes, we have done some changes. They were relatively minor. We've seen that we have interwoven part-timers and full-timers, which is very interesting for them because some of them are working and studying and others are full-time studying. And we've seen that they really want to benefit from each other, but that we need to find more windows where they can actually work together. So it was that we adjusted the program in that perspective slightly. Other changes we have done, we're starting now as the program grows, is that we offer additional modules that students can choose from even further if they want to intensify their knowledge in a special field.
Okay, the last question is, do you consider that VDC can become mandatory in public projects, just as BIM already is in some countries?
Sorry, you have to, if BIM is mandatory in some countries, or you have to ask again.
Yes, Nora. So the question is, do you consider that VDC can become mandatory in public projects just as BIM already is in some countries?
Sorry, thank you very much. I think it would be helpful. I'm always very careful if I say something has to apply for everything. So this is always the moment where I say you cannot solve everything over making regulations. But I do think it would be helpful to push it more. And obviously, if you do a regulation, that automatically pushes that field further.
Okay. Once again, we appreciate your participation and move on to the next speaker.
Thank you very much.
Okay. Para la siguiente exposición, les recordamos otra vez que se contará con traducción simultánea por si desean escuchar la ponencia en español. Para ello deberán activar la opción de intérprete ubicada en la pestaña inferior. Asimismo, les recordamos que las preguntas formuladas serán respondidas al finalizar la presentación del ponente. A continuación, invitamos al ingeniero Lauri Cosquela, quien es uno de los promotores más importantes de la filosofía Lean Construction. Desde 1991 ha desarrollado investigaciones relacionadas a la construcción Lean, promoviendo la idea de la administración de la producción en construcción, cuyo objetivo fundamental es la eliminación de las actividades que no agregan valor. Es uno de los académicos más citados en gestión de la construcción y campos afines, con más de 7.800 citas, según Google Scholar. Se ha desarrollado como profesor de construcción y gestión de proyectos y profesor de gestión de producción y proyectos basados en la teoría Lean en la Universidad de Huddersfield y de Salford, respectivamente. Lauri, actualmente, además de desempeñar su labor como docente, es un referente activo de la industria, pues regularmente se encuentra realizando charlas o conferencias acerca de Lean como apoyo a la industria y a la academia. Thanks for your participation and go ahead, please, Engineer Cosquela.
Thank you very much for the introduction. I tried to have the video on. So my topic is approach to Lean and the synergy between the digital and Lean. Thank you very much for inviting me. I am providing a bit of an external view on VDC. As many of you know, I've been active in the lean construction movement, and I was lucky to be in the position of being there when it started in '93 or so. And actually, one could say that both this VDC movement and the lean construction movement started at Stanford, because I developed it in 91, 92 and of course met Matti Fischer, John Kunz, and others at that point. I apologize. I have had massive computer problems in the recent days. My work computer stopped working, and I have been working on a temporary fix with another operating system, and it has been very difficult. Please, next slide. So my understanding on VDC is probably outdated. So I have the ideas in fresh mind that John Kunz spoke 30 years ago. I'm not up to date what VDC is at the moment. But from my friend Leonardo Schmuller, I understand that there are at least two heavy parts in VDC: BIM and the digital in general, plus lean, and perhaps some good project management in addition. So VDC is a technology-centered approach. Lean is a management centered approach. VDC sees lean as something helping. Actually, lean sees BIM as something helping. Next slide. For 30 years, I have been looking at lean and have tried to create a simple understanding on it. And it is the same as a theoretical understanding, because theories are usually very compact and they provide understanding. So next slide. The most common understanding of lean is tool-based. And this is extremely important. And this is how lean gets implemented. And this the tools need to be mastered by those who seriously want to implement lean. There's a very good book on lean construction by Amstott and Fauchier, and they list the central tools like here. And of course, the first tool is not a tool, collaboration, but it is significant that they have listed that as the first tool. There's last panel system, extremely important for lean construction, and then there are other tools which are coming from the Toyota production system. So, next slide. This is not all. I have been claiming that lean is a theoretical and philosophical innovation. So there has been a theoretical conceptual shift. Just the big problem is that it has not been explicit where we have been earlier regarding theories. So this shift is not easily understood. However, it is about how we see production, how we acquire knowledge, and how we see world to be. Next slide. So usually we don't speak about theory of production, but we are using some theory of production all the time. So I have been arguing that lean is an innovation on 3 frontiers, that theory of production, then a part of philosophy, ontology, and another part of philosophy, epistemology. And this corresponds to what I said on the previous slide. And next slide. I have been claiming that the transformation theory of production is being replaced by 2 other theories in lean, namely flow theory and value generation theory. The transformation theory looks at production as a black box that can be decomposed into further black boxes. And this is, of course, the idea of work breakdown structure in project management, in cost management. The flow theory brings time and uncertainty, which are causes of waste, into the analysis of production. And then there's another theory, value generation theory, which adds the customer and value into the picture. Next slide. If production is not discussed theoretically, so we engineers speak even less about ontology, except in computer science perhaps, and epistemology. So regarding ontology, lean is supported by process ontology, which stresses the changing and relational nature of phenomena. The earlier and still mainstream approach is thing ontology, where ideas of stability and decomposability of things is emphasized. Regarding epistemology, lean is Aristotelian in the sense of two-way traffic from ideas to the world. The mainstream counterpart is Platonism, where the traffic is in one direction from ideas to the world. Engineering sciences have traditionally been extremely Platonic. I'm not going further. It would require a long presentation to deal with this, but in this first reference, COSLA 2020, there is a longer explanation of all of this. The next slide. In practice, it's rather easy. You or your organization is lean if you are pursuing elimination of waste and increase of customer value. So this is the production part. If you are learning from outcomes of action through PDCA cycle, and this is the epistemology part. And if you are continuously improving. So this is the ontology part. Just when the theory of production, epistemology or ontology are not visible, we are not discussing them. So many people who say have a thing ontology filling their mind cannot easily understand what when being is explained in these simple terms. Next slide. What is the relation between the digital and lean? And the next slide. A first idea could be that Beam and lean are additive. So we implement Beam and digital, we have benefits, and then on top of that we implement lean and we have further benefits. Next slide. No, this is not so. For 10 years already, it has been argued that Beam has lean. Beam is contributing to lean. So Beam creates benefits through lean. And there's much literature on this. The other direction, lean contributing to Beam, has not been looked at that much, but it is there, and I'm arguing that it's important too. Next slide. I'm not going into this 2010 paper looking at the interactions between Beam and lean. Rather, let's look at a fresher case, how lean is contributing to Beam, and of course this direction was not looked at in that paper at all. So we have been collaborating with an engineering design company which is dealing with highways design, and we have tried to support lean implementation in this regard. When looking at how clash management is being done, so we were very surprised that when the detailed design stage started, so there's a huge inventory of clashes, 8,000 or so clashes, and then the designers start to eliminate those clashes. So there has been a totally silo-based approach in different disciplines, and there are so many disciplines in highways, and of course all is in a flux, rather new software, and so on. So there are kind of excuses. Next slide. So, however, the situation cannot be seen to be satisfactory, and actually the client, when observing the number of clashes, was horrified and thought that the maturity of design was very low, and delays could be extended. So we applied the lean methodology to this. We tried to find the key root causes. And of course, there were modeling errors, there were errors of coordination, and also things which are a bit difficult to understand from outside. So there were expected or intentional clashes, which are left to the side to sort out. And somehow it was claimed that similar clashes are counted many times. Based on these root causes, and the next slide, countermeasures were developed, and they deal with the process itself, structure and transfer of information, and standardization and automation of time-consuming activities. Next slide, please. So the process of clash management was informal. So one of the first steps was to create a process map of the as-is situation, and then should be situation in which, and here with those star burst pictures, we indicate where most important changes are needed. And next slide, which gives an indication on the contents of the stages, and also on the countermeasures. Without going into details, just to give kind of an impression on how lean is being inserted here. So of course, early identification of client requirements, which I understand is very much a part of VDC, standards, process mapping techniques, and then a one-piece flow rather than batches. This is at the heart of lean. One-piece flow for dealing with clashes. Mistake proofing, another key part of lean. Improve process standardization, automated approach when possible, flow management and control approach, systematic waste analysis, and so on. So there's a wide variety of lean techniques that can be used for improvement of this clash management process. And of course, we know that clash management is touted as one of the key benefits of BIM, but it doesn't come by itself. There must be a process, and it can be improved and managed through lean tools. Next slide. Then a fresh example of this digital to lean direction, and this is about digital whiteboard technology, which has been used in the context of last planner management of design in the same company. And especially when during COVID-19 people started to work from home, so it was almost a necessity to find something like the digital whiteboard. For that, LPS, last planner system meetings, were physical meetings where information was presented or communicated by as we know, by projecting computer screen to the wall, by sending information through email, and so on. Next slide. Now, it's interesting to compare a physical whiteboard to the digital whiteboard. Physical whiteboards are used in lean meetings and otherwise. So a whiteboard is visible to everybody in this space where the whiteboard is. Digital whiteboard is visible to everybody who has access, irrespective of location. Physical whiteboard is in operation during a session, a meeting. Digital whiteboard is in operation during the meeting, but between the meetings. Anybody can write in both cases. Physical whiteboard has a limited area. A digital whiteboard has practically unlimited area. Of course, unlimited area cannot be used, but much information can be presented there. Next slide. So when evaluating the last planner system application, so it becomes evident that a digital whiteboard is a very effective way to communicate concepts, ideas, actions. And actually, in this company, the digital whiteboards were introduced through last planner system, but very soon 8 other applications were developed by those people who had learned to use a digital whiteboard product in this context. So it helps participants to contribute to faster problem solving. Information can be accessed before and after the meetings. A common ground is created, and it allows for collaboration, which of course is at the heart of lean. And all in all, it hugely extends the scope of applying visual management, which is a heavy part of lean. Next slide. We come to the end of my presentation. I wanted to show that there is this two-way traffic from the digital to lean, from lean to the digital. Here, reference 1 is where my current view on the theory of lean construction is presented. References 4 and 5 are regarding these two examples, and then we have this 7 Amstott and Fauchier book. Actually, it is an extremely good book on lean. When developing this presentation, so I realized that there has been too little interaction between the VDC community and the lean community. So we just should compare our notes more and more often. thank you very much for listening to me, and I look forward to any comments and questions.
Yeah, thank you very much, Professor Koskela, for sharing the synergy between lean construction and the digital environment. We have the following questions for you. Professor Koskela, how can someone introduce lean to a construction company that has never used that philosophy before? And which should be the first steps?
So many companies have had the last planner system of production control as the entry point. And 10 years ago, 20 years ago, and still it is a good entry point. Probably it is a good idea to recruit a consultant, a facilitator of last planner. Last planner provides a basic stabilization of production, and after that has been done, so other methods can be introduced too. And of course, now there are other methods for production control in lean construction, like the line of balance methods and the tact planning methods. I just don't know whether it would be possible to start with tact planning, but the majority of experience says that it's good to start with last planner, and then perhaps proceed to tact planning and control.
Okay, thank you very much. And the second question is, do you consider that industrialized construction can eliminate all the waste that may occur during traditional construction processes?
So the idea of industrialized construction has been there since Henry Ford started to use the moving belt. It has been for 100 years. And to me, the puzzling thing is why industrialized construction hasn't advanced more than what has happened. It's quite possible to be wasteful with industrialized construction. It needs better coordination than site construction. But on the other hand, if kind of management is good, and if management is lean, so industrialized construction can be very efficient. But it's demanding. It's more complex than in situ construction.
Sure. Okay, once again, we appreciate your participation and move on to the next speaker.
Thank you.
Ok, para la siguiente exposición les recordamos que se contará con traducción simultánea. Por si desean escuchar la ponencia en español, deben activar la opción de intérprete ubicada en la pestaña inferior. Asimismo, les recordamos que las preguntas formuladas serán respondidas al finalizar la presentación del ponente. Ahora, damos pase a Ulima Majumdar, la cual es candidata a doctorado en la Universidad de Stanford con especialización en diseño y construcción virtual. Está interesada en la intersección de la construcción y el uso de la tecnología. Ha trabajado en diversos países como Estados Unidos, Australia e India. Grandes empresas como Deloitte, Infosys y pequeñas como Davis London y CleanTQ. Posee experiencia en el uso de la realidad virtual en la construcción hace más de una década. Thanks for your participation and go ahead, Engineer Majumdar.
Okay, I thought that it was just at my end. Okay, thank you so much. Good evening, everyone, and thank you so much for this opportunity. I am so excited to present to all of you a little bit, mostly about my research, but also a little bit about how this research came about. My name is Tulika Majumdar. I am currently a researcher at SciFi. Professor Martin Fisher is my advisor. I also have worked professionally in the industry at companies such as Infosys, Deloitte, and AECOM. And I will come back to the comment that that Martin made a little bit earlier about how the life of a student is somewhat easier than the life of a professional. Okay. So this is a quote that my father would often use. If one does not know to which port one is sailing, no wind is favorable. This is a quote by Roman philosopher Seneca, very intuitive, but I'll come back to it later. And this picture, all of you are familiar with, I think by now. This is 2022. We all use ride-sharing apps. And when we go somewhere, we enter a very precise destination, right? Without which we might just end up somewhere else. So this is what happens in day-to-day life. But when it comes to construction projects, our project destinations are not as precise. The precision just goes away. This is from one of my projects that I was working on in 2017 in Australia. And the project definition that the client gave us, if I can call it, the destination was efficient and accelerated project lifecycle. There was more to it, but what I'm trying to say is that this imprecision often leads to project teams fumbling around and not having something tangible to work with, no matter which tools, technologies, and processes they use. Nora made a point earlier about, tools standing just by themselves really will not solve your problem. And we see this often, right? We see clients defining their objectives as, we want a sustainable building, or if it's a new road construction, we want shorter travel time. So why I'm saying all this is that this precision, we need more precision in order for methodologies such as VDC to really be effective. So a good project objective or client objective, I'm using now these terms because this Congress has been going on for the last 3 days, and you all are hopefully now familiar with the terms. It guides the project team. If a good client and project team guides the project objectives, guides the project team towards a logical path of action through the completion of the project. It is realistic, it is challenging, and it is quantified, which the example that I showed you was not clearly, right? So project objectives are important because they really define what the project team should achieve at project completion. On that project that I was working on, eventually we boiled it down to reducing the construction duration from 40 months to 18 months, right? And while the definition of this destination is really important, a precise definition, the destination is elusive without timely course correction. What I mean to say is, this is again, let's go back to our 2022, we're in an Uber or a Lyft, and the driver has taken off. But if the driver is not keeping an eye on, whether there are any road closures, anything else happening on the route, and doesn't do timely course correction, how likely are you to reach your destination on time or even reach at all, right? So really, it makes me think when I think about, so metrics are a very, very integral part of the VDC methodology. But when I think back about my professional life, and I think about how we were, defining the project objectives, client objectives, and working towards them, it makes me feel like we are back in times like 1492, when Christopher Columbus set sail from Spain to reach India. However, we don't know what happened during the navigation. Maybe they weren't doing it. My thinking is that the navigation system was not sophisticated enough to really guide them on a regular basis where they were headed. And instead of India, the ship actually landed in the Bahamas. And we don't want that to happen on our projects. And this is where I think I want to go back to Martin's point about being a student is easier than being a professional, because here is where it's easy. Now that we have the VDC terminology and a common vocabulary through the VDC framework, it's easy now to talk to people about defining their client objectives, project objectives, and production metrics, which you measure on a regular basis. I didn't have that vocabulary when I was working as a professional on that project. And so this problem became that of a change management. And it becomes even more complex when the client is a group of people who are all at different levels of understanding in understanding of objectives, metrics, or modern management methodologies, such as VDC. So from here on, my presentation is only going to be about production objectives or production metrics, which we track on a daily or weekly basis in order to reach the project and client objectives, right? They are daily or weekly in nature. We are all familiar with the milestone-based method of managing projects, right? More traditional, there is a project start date, there is a project end date, and we have some milestones in between. This is a good system, except the feedback loops from milestone to milestone often tend to be too long. And by the time the project team tries to make up for a milestone that was missed, there is a ripple effect on the milestones that are coming up. And that often leads the project to fall off track. Production metrics, they really complement the milestone-based method because they are daily, weekly in nature. So think of them as small yardsticks that give you much more rapid feedback. If in the same example that I just showed you, if there were, instead of just one feedback at the end of milestone 1, there were, say, 8 feedback loops, then the feedback is more rapid, and this makes it possible for rapid, timely course correction, which then makes it more likely that the project will complete on time, it'll achieve its objectives, right? So production metrics really are the link between the actions we take on a regular basis and the outcome we expect at the end of the project. I'm going back again to my project that I was sharing with you, where the schedule duration had to be reduced from 40 months to 18 months. Once the client decided on this project objective, they were really focused on technology. And that's a picture of me trying out some VR solution with my colleagues. That's a different story that the client never made up their mind which technology to go with. But nonetheless, we are trying. And these are the actions and decisions that we take on a regular basis on a project, right? Which technology to use, who to hire, what sort of process or workflow to use, in the hope that we will ultimately meet our client and project objectives, which in this case, the client really cared about the throughput that would come from the plant, and they wanted a reduction in the construction duration. So while controllable factors really vary a lot, the yardsticks that you would use to measure these actions, my hope was that there would be some similarity in the things that you would measure, which are output metrics as a result of the actions and decisions taken, right? Now, and so this is how production metrics really impact the client and project objectives. Really, these client and project objectives motivate the actions and decisions that you take on a regular basis, and they impact the overall client and project objectives, but so do the production metrics. And the feedback loop between the production metrics, things that you measure on a regular basis, and how they inform the changes that you make. This is where my research interest was. Now, the problem is, which production metrics to track? Thinking back upon this project again, I was wondering, what was my difficulty? First of all, of course, we had the difficulty of really whittling down the project objective to, that schedule duration. But at the same time, I didn't really know at that time Well, I have some idea now, but at that time, I definitely didn't know. How would we assess, even if this technology that we are trying to use, how would we assess whether it is really working or not, right? If I knew that other people who are using all sorts of technologies, they are using production metrics such as, were the technology criteria, evaluation criteria established? How many solutions or how many evaluation criteria were satisfied? Or how many solutions are we evaluating per week? Or how many decisions are we making per week? Then my task probably would be simpler, but this is only in retrospect that I'm able to understand and appreciate. So if we look at other industries, such as manufacturing, they have a standard list of production metrics. There are papers published, and even if you do Google, if you just Google on production metrics in manufacturing, you'll see a list of some standardized 30 to 40 production metrics: cycle time, asset utilization, work in process. There is no such list in the construction industry, no industry-wide standard list. People do track something or the other, but it's not like there is a consolidated list somewhere for ready reference. And that was something that really surprised me when I came back to Stanford as a researcher. And I was wondering, so how should we go about building a go-to list of production metrics for construction? Now, the truth is that while project teams do, measure something as they go along, and they are constantly, hopefully, doing course correction, the knowledge or whatever they're doing, that stays within the project team itself. So either they don't track, or if they track, that what they're tracking is not shared across projects, even within the same organization. That is something that I noticed when I started working with Martin on the VDC certificate programs that SciFi runs in collaboration with PPI and SCPD, and now along with the University of Lima and the Norwegian Technical University, NTNU. So while I was grappling with this question, we realized that there has been a recent uptake in the VDC adoption. And we can see this graph here shows the number of certificates given to the VDC participants who've enrolled in the VDC certificate program over the years. The program started somewhere around 2008, 2009, and now it has really picked up. We are running the large-scale VDC certificate programs. We started this in 2019. And this made me think that we have so many people, a large number of people who are implementing VDC in different parts of the world in projects. And because metrics are such a fundamental part of the VDC methodology, surely they are tracking metrics, and we can make use of this knowledge that is coming from so many projects that are being done at the same time, following a similar methodology. And I changed my question somewhat from how to build a go-to list of production metrics to which production metrics are VDC professionals finding useful. The assumption is they are using the ones that they are finding useful. And this is something we noticed. At the start of a VDC implementation, typically people start with a large number of production metrics, and then they whittle it down to a few as the project progresses, and they realize that some metrics are not making much sense. So this is a picture of the first large-scale program that happened in Norway, and I was lucky to be supporting Martin and the other mentors in this program as they're here. And over the years, we now have data from 600 plus AEC professionals who have participated in the large-scale program, and as a result of that, have provided us with the production metrics data. And these are, of course, run in collaboration with SCPD, Ulima, and NTNU. So we went through the monthly reports that people have been submitting, the participants in these programs have been submitting, and we curated 2 data sets of production metrics from the first large-scale program in Norway and the first large-scale program in Peru. And I'm using Scandinavia and Latin America because in the program in Norway, we had participants from Sweden and Denmark as well. And in the program in Peru, we did have participants from Brazil, maybe Colombia. But yeah, so in general, as I keep referencing these 2 data sets, data set 1 is Scandinavia, data set 2 is Latin America. And this was an opportunity to really study the production metrics that 175 professionals from Scandinavia had found useful and 104 professionals from Latin America had found useful, right? The professionals came from a wide variety of companies representing general contractors, engineering and design firms, architects, subcontractors, and owners even. So while I was hoping that ultimately it's VDC, ultimately people are measuring, on a regular basis these production metrics, there would be some, I was hoping for a limited number of production metrics that would emerge from this analysis. I was really surprised that there was actually much more. There were much more production metrics that were reported. You can see that from the first data set, which is the Norway data set, 1,320 total production metrics were reported. And from the Latin American data set, 650 total production metrics were reported. Also, now this data was all in Norwegian and Spanish. So it was a bit challenging to translate them and understand them. But the first thing that struck us was that everybody is inventing their own production metric. So in order to make sense of this data, we needed to, first we clean the data. As I said that, when I was talking about metrics earlier, when I was talking about actions and decisions, these are input metrics. These are not things that you measure. These are things that you decide to do along the way. So those were removed from the data. Vague production metrics, such as problem solving, digitization of tasks, we removed those. We also removed client objectives and project objectives, things that you measure at the end of the project. We also removed objectives that are measured at specific milestones and not on a regular basis, on a daily, weekly basis. And once we had cleaned up the data, we prepared a combined list of 17 production metrics that we found in the literature to label the curated data set so that then we could start seeing the comparison, the similarities and the differences. The metrics from the literature, production metrics from the literature were based on an early paper that is actually written by Professor Martin Fisher and John Koons from SciFi, and another one from by Eilif Helseth, the professor at Norway, who has really spearheaded the Norwegian large-scale program, he and his colleagues. So we combined the production metrics that they have recommended, and we published a paper with our findings. What we found was that of the 17 production metrics in the literature, 3 have been heavily used or reported in the data sets that we were studying. The first one was detailed schedule conformance, the second one was stakeholder involvement, and the third was meeting efficiency. These were reported by more than 40% of the professionals in both the data sets. Then there was a second group of production metrics which were very lightly used, reported by less than 10% of the professionals in both the data sets. I was quite surprised to see decision latency in there because as we have seen on projects, decisions that are not taken on time are the ones that really, make the project fall off track. There were metrics on detailed cost conformance, field material delivery, meeting agenda appropriateness, client satisfaction, safety and visualization that very, very few people reported on. And then we had production metrics which had a discrepancy in reporting between both the data sets. They were meeting effectiveness, response latency, field generated RFIs, rework volume, BIM coordination consistency, budget estimate conformance, and root causes for plan deviation. Again, root causes for plan deviation I was quite surprised by, because if you're tracking detailed schedule conformance, then I would expect you to track the causes for plan deviation as well, right? So as we looked at the results, we also realized one thing. Of course, it gave us good insight into similarities and differences, but also it seemed like VDC is now reaching somewhat of a maturity, at least among people who are enrolled in the certificate program, right? Who know VDC. And so we thought maybe a more current classification or categorization of the production metrics is required, because the older one has individual production metrics, such as decision latency, and it has categories such as safety, visualization, or even detailed cost conformance. There could be multiple production metrics under them. So at this point, we thought we should, and when I say we, I am using myself and my co-authors, my research collaborators from Norway, Peru. Alexandra is one of them, and of course, Professor Fisher. So we wrote another paper. We classified the production metrics, the same production metrics that we had used in the previous study, by using ICE, BIM, and PPM. Now that these are, the three key pillars of VDC that the VDC community is familiar with. The idea was to have BIM, ICE, PPM at the top level, and then have subcategories of production metrics, and under them, individual production metrics. Now, this is still a work in progress. So I will just talk about the highest level, not the subcategories. What we saw was that ICE and PPM production metrics were reported by more than 65% professionals in both the data sets. BIM, interestingly, was reported by only 30% of the professionals in Scandinavia, but by 91% of the professionals in Latin America. So now this could be because most of the projects that the professionals in Scandinavia represented were infrastructure projects. And there have been studies on how BIM is either, the BIM tools are more used on building projects, or perhaps it could be that BIM as used on buildings, the production metrics are reported more, such as hard clashes. So we haven't really dug deeper into that. But what we saw was definitely that ICE and BIM are, being used by both in a similar way. The next thing I was curious to find out about was how integrated are these pillars of VDC in how integrated are the VDC practices. VDC theory says that you should be using ICE, BIM, and PPM all together, right? But in reality, what is the case? So interestingly, we found that while in the Latin American data set, 68% of the professionals used ICE, BIM, and PPM, all the three. From the Scandinavian data set, only 17% used all three. Also, it was interesting to note that ICE and PPM, again, it could be because of the project type. 40% of the professionals in Scandinavia were using ICE and PPM, whereas only 16% in Latin America used ICE and PPM both. It was good to see very few professionals using just one element. So the results were similar, somewhat. We had expected somewhat of a spread and some similar trends. So not very surprising, but yeah, I was a little surprised that only 17% in Scandinavia were using all three elements. So these were basically, so far we were at production metric category level. Now we were curious to find out which production metrics are really making it to the top 10 production metrics, individual production metrics in both the geographies. And while this is again, work in progress, I'm not sharing all the results, but we were able to see, I'll just report on the differences. So production metrics, which were in the top 10 in Latin America, but not in the top 10 in Scandinavia, were decision latency, number of solutions developed in the ICE session, and these are ICE production metrics. For BIM, we saw that spatial or geometric clashes and clashes resolved in the ICE session were reported or made it to the top 10 production metrics in Latin America, but not in Scandinavia. And under PPM, the number of RFIs and the rework hours, these were the ones that were in the top 10 in Latin America and not in Scandinavia. Then we also looked at the data just specifically focused on production metrics that were reported by project managers in both the regions, because we thought maybe there is a difference in the production metrics people report just based on their role. So the top two that project managers from both the regions reported were percent plan complete, PPC, for tasks, and the number of participants who attended the ICE sessions. This one, it says attended the session, it means ICE sessions. And while again, so these, the blue bars are the production metrics that belong to the ICE category, green is BIM, and red is PPM. These are the results from the Latin American data set, and corresponding to them, the gray bars are the ones from Scandinavia. So you see that there's a similarity and there's also a difference. And this is what I'm trying to get to, is that, is there a rhyme or reason why this difference? Could it be based on the project characteristics? Could it be based on the role of the person who's actually reporting this production metric? Or is it that certain production metrics are just difficult to track or measure? So those are where we are those are the things that where we are headed next. But why does this research and results really matter? And if you think about it, by creating this classification, ICE, BIM, PPM, and then the subcategories that we will propose in the next paper and the individual production metrics, we are really creating a common vocabulary of production metrics. I mentioned earlier that there are two scenarios. Either people are not tracking any production metrics, or even if they're tracking, somehow, what they are tracking is getting lost because there is no common vocabulary yet. So by creating this common vocabulary, we hope that this will enable comparison across projects and so facilitate benchmarking. It'll enable repetition of VDC practices, so allow companies to do continuous improvement. So if I go back to the project, my Australian project, we were trying to use VR. Well, the client didn't make a decision, but if they had, and we were seeing good results, then that would be a practice that they could use on future projects, right? Using VR in the design phase. It facilitates, this common vocabulary facilitates strategic decisions and standardization of metrics within an organization. So say a company, now that VDC theory says that we should be using all the three elements, and a company notices that, on so many projects, 10 projects, we have been reporting ICE and PPM production metrics, but we're not reporting BIM. Maybe it's time to do a strategic hire. Maybe it's time to train our employees on the latest BIM tools. Now, such strategic decisions can then be taken. And standardization of metrics within an organization. I was very surprised when I first joined the PhD program and I was working on an individual VDC certificate program with a large general contractor. I was quite surprised to see that within the same organization and similar projects and people working on similar projects, even they didn't have, a standard list or a way to communicate with each other that, oh, the hospital project, of a certain size, we've been using these production metrics. Maybe you should also do that. It's a building project, it's a hospital, but there wasn't any, there's no common vocabulary, no standardization. So this will facilitate, hopefully, this standardization within an organization and facilitates industry collaboration. This I'm noticing already. Through the VDC certificate programs, what I see them as, I see them as a VDC community building opportunity. It's almost like a movement. And now that we are armored with this language of production metrics and project objectives, client objectives, this common vocabulary of production metrics will help and facilitate further collaboration with industry and, of course, benefit the research community as well. And I think I would like to end the presentation with the metrics framework and the VDC framework. You all are very familiar with it, but still, if I were to again go back on some of the projects that I have done where I didn't use metrics, I would like to go about using VDC like this, using this framework, really asking, why is the client doing the project? What does the project team need to achieve? Your client objectives and project objectives get answered through that. And now how are we accomplishing those project objectives, which is where production objectives and controllable factors come in play. And hopefully my research will inform some of the fuzziness around production metrics and controllable factors that we have right now in the industry. So with that, I would like to acknowledge all my research collaborators, starting with Professor Fisher, who for his leadership and his enthusiasm for VDC and for always encouraging us, for Alexandre also for his leadership in VDC education and for always providing me with input and helping translate all the Peruvian data. Our collaborators, Alif, Steinar, and Catherine from Norway. All the mentors from the first large-scale program, especially the ones in Norway, they really helped me understand, interpret the production metrics, Norwegian production metrics. And Alexandre and his students, they helped with the Peruvian data. All the professionals, of course, who participated in the first large-scale VDC certificate program in Oslo and in Lima, because if they hadn't reported sincerely from the projects that they were working on, this research wouldn't have been possible. And earlier there was some discussion around how VDC is enabling this cross-pollination or collaboration between industry and academia. And I'm seeing it firsthand. And this is, it's an enjoyable journey for me. It's also eye-opening. And I always learn something and I think back retroactive. Okay, if I were to go back to my projects, how could I use this? And of course, my SciFi colleagues who are always there to bounce off ideas and provide their input on my research. So if you have any research or industry collaboration ideas, or you just generally want to talk about production metrics or how to manage projects with metrics, please look me up. Shoot me an email at tulika@stanford.edu. And I am happy to answer any questions if you have. And thank you again for the opportunity.
Okay, thank you very much, Engineer Mayumbar, for your presentation and your participation in this Congress. It's really interesting to see how the application of VDC improves productivity in projects. We have the following questions for you. The first question is, do you think there are production metrics that must be replicated in projects of the same kind?
While this is something that I'm still investigating, that, is there a similarity in the production metrics across project of similar type, size, etc.? But we have seen some metrics which people are finding useful regardless of project type. So PPC, for instance, and I believe that PPC is something that every project should track, right? It doesn't really have to be of certain type. And many such production metrics, rework hours, decision latency, they're applicable to any project. So, yeah.
Okay. The last question is, did you relate metrics comparison results versus client satisfaction versus project goals?
Yes, so that is something which we haven't done because I have really focused on production metrics and not so much the link between the production metric and the client and project objectives. Also because results of the project objectives, to get those results, I will have to wait till the project gets over, right? Yeah, I mean, I could do whether they're on track or not, but no, that is not something I'm focusing on right now. It is a logical next step to our research.
Okay. Once again, we appreciate your participation and move on to the next speaker.
Thank you.
Okay. Thank you so much. Ahora queremos compartir con ustedes un video informativo del programa internacional VDC desarrollado por la Universidad de Lima en colaboración con la Universidad de Stanford. Okay. Recordarles que el 22 de agosto se llevará a cabo el programa Virtual Design and Construction en colaboración con la Universidad de Stanford y la Universidad de Lima. Para mayor información del programa pueden contactar con nuestro asesor de ventas, Oscar Carrasco, cuya información encontrarán en el chat. Continuando con nuestra programación, compartimos con ustedes las experiencias de 2 certificados del programa internacional VDC, desarrollado nuevamente por la Universidad de Lima en colaboración con la Universidad de Stanford. Nuestro primer certificado es Juan Carlos Maita, jefe corporativo de planificación y control de proyectos en Compañía de Minas Buenaventura.
Buenas noches a todos. En esta oportunidad quiero agradecer por la invitación realizada por la Universidad de Lima, Stanford University, en el marco del tercer Congreso Internacional Virtual Design Construction, del que todos ustedes están siendo partícipes durante estos días. Bien, en esta oportunidad quiero compartirles la presentación que he elaborado justamente con el objetivo de poder transmitirles alguna de mi experiencia en cuanto a la implementación de esta metodología de gestión colaborativa. ¿Ok? El título de mi presentación se denomina Implementación VDC en proyectos mineros. Vamos a hablar sobre la perspectiva del owner o la perspectiva del propietario. ¿Ok? Bueno, quiero empezar presentándome en primer lugar. Con quien les habla es Juan Carlos Maita Checasaka, certificado no solo como VDC, sino también como PMP, PMOCP y MBA. Soy ingeniero civil de la Universidad Nacional de Ingeniería, Perú. También he tenido esta maestría en SAM Business School. Ya hace un par de años tuve la oportunidad de hacer algunos estudios también allá en China, que pude complementarlos en los temas de negocios. Y bueno, aparte soy catedrático en la Universidad Nacional de Ingeniería, en ESAN, también ahora en la Universidad de Lima, y bueno, y otras instituciones como Costos Educa. He tenido la oportunidad de ser ponente internacional en algunos eventos durante la pandemia, el 2020-2021. El Project Control Expo es un evento virtual de los más grandes a nivel global, para la redundancia, y dentro del PMO Global Awards, ¿no? Siempre transmitiendo nuevos conceptos, nuevas ideas dentro de toda esta ola de transformación digital que vamos a ir conversando, y además dentro de cómo VDC me ha permitido ayudar a apalancar este tipo de iniciativas. ¿Okay? Bueno, me desempeño como jefe corporativo de planificación y control de proyectos en Compañía de Minas Buenaventura. Vamos a hablar ahorita un poquito más de de la empresa Buenaventura, que es la compañía en la que llevo ya casi 3 años y medio, ¿no? Y algo que no saben de mí, pero sí me gusta bastante transmitirlo, es que soy miembro voluntario. Me gusta compartir conocimientos, enseñanzas, mentorías, y dentro del ASE y el PMI he encontrado un poquito esa oportunidad, ¿no? También soy miembro directivo de la red VDC, trato de contribuir en la medida de mis posibilidades con la red VDC y también con la acción de control de proyectos. Y bueno, algo que también me gusta decirlo y pocos lo saben es que soy muy apasionado no solo de mi trabajo, de lo que yo hago, del mundo de gestión de proyectos, sino también de poder contribuir en dejar este mundo un poquito mejor. Y creo que siendo voluntario activo, por ejemplo, de Crea Más, me ha permitido poder ayudar a jóvenes talentos de etapas escolares en la que uno puede ir generando este cambio, ¿no? Como se le denomina en el refrán que ellos tienen, talento creando cambio. Bueno, esto es un poquito sobre mi reseña. Quizás algunos de los que me conocen o me han visto en algunos webinars saben un poquito más de mi background, pero quizás algunos no. Entonces, en esta oportunidad, pues les traigo una línea de tiempo. Prácticamente me he desarrollado en la línea de Project Controls en empresas de reconocido nombre aquí en Perú, como el grupo JJC, COSAPI. Estuve en un consorcio en 2011 ya por Colombia, una experiencia extraordinaria, ¿no? Y luego a partir del 2012, pues tuve la oportunidad ya de asumir cargos cada vez más retadores, ¿no? Con mayor necesidad de liderar y gestionar también el cambio. Entonces, estuve en JJC, en la primera JJC, obras de ingeniería y ahora como compañía de minas Buenaventura. Y bueno, como le dije, yo soy ingeniero civil de profesión, muchos años me he desempeñado dentro de este mundo de control de proyectos y netamente como contratista, teniendo experiencias también como proyectos EPC y EPCM, ¿no? En Colombia, por ejemplo. Pero he encontrado dentro de minería esa posibilidad de poder completar todo este círculo de conocimiento. Y ahorita lo van a ver, ¿no? Es que como owner, pues tu perspectiva es otra, ¿no? Y te pones la camiseta de propietario, ¿no? Y hay que defender los intereses. Bueno, continuando un poquito la agenda, les he traído 4 puntos. De hecho, los 3 primeros puntos y el cuarto que son conclusiones yo le he puesto a nivel de un bonus track de mi parte, ¿no? Me gusta siempre dar un poquito más de lo que me pide. Bien, empecemos. Introducción. Dentro de lo que es el Perú, ¿no? Si nos situamos dentro de todo este mapamundi, pues podemos ver que Perú es reconocido no solo por su gastronomía, ¿no? No solo por ser quizás bastantes, digamos, arraigados en nuestra cultura, ¿no? Siendo embajadores de una marca tan peruana, sino también somos un país minero. No debemos olvidar eso. De hecho, uno de los principales motores dentro de nuestro país no solo es la construcción, también es la minería. Eso es un principio clave que todos deben conocerlo. Y dentro del Perú, pues, no solamente hay empresas mineras nacionales, también hay transnacionales. Entre ellas tenemos a Barrick, Antamina, MMG, Las Bambas, ¿no? Explotando ahorita, perdón, terminando ya la etapa de construcción del proyecto Quellaveco. Están Sur, están Yanacocha, están Volcan, están muchísimas empresas mineras, tanto de gran minería como de mediana. Pues bien, Compañía de Minas Buenaventura es una empresa peruana, justamente, que se dedica a la explotación de metales preciosos y básicamente se centra en su producción en el Perú, en algunas de las principales minas que voy a mencionar a continuación, ¿no? Tenemos la mina de Tantahuatay, tenemos la mina de La Zanja, está la mina de Uchuchacua, que está aquí en la Sierra de Lima, la minera Sociedad Minera El Brocal. Justamente es la mina donde está situado nuestro proyecto caso de estudio. ¿Ok? Pues también tenemos otras minas como son Tamomayo, San Gabriel, que ahorita lo estamos empezando, Copampa, y bueno, y Cerro Verde, que de alguna forma no está operada directamente por nosotros, pero tenemos cierto porcentaje de acciones compradas ahí. Entonces, primer punto, o segundo punto en todo caso, Perú es un país minero, y segundo, Buenaventura opera dentro de este país minero. Una de sus principales minas a explotar es Sociedad Minera El Brocal, y es una mina que explota cobre a nivel subterráneo y que explota zinc a nivel de superficie. Bien, Sociedad Minera El Brocal, como le mencioné, es una mina a tajo abierto y underground, y está localizada en el distrito de Tintayhuar, provincia de Pasco, departamento y región de Pasco, situada a 4.200 metros, poco más de 4.200 metros sobre el nivel del mar. Y como ya les había adelantado, pues procesa minerales de cobre, plata, zinc, etc. Está operando justamente con dos plantas concentradoras. Como se puede ver aquí en la imagen, la ubicación de dos áreas de chancado, molienda, flotación. Pero nosotros vamos a hacer el caso de estudio en una de ellas, ¿no? Justamente en el área de chancado secundario de cobre, ubicado en la planta número 1, que es la que está en la parte inferior. Y bien, esto es importante entenderlo porque todos los proyectos son distintos. Este es un proyecto de un reemplazo de equipos estratégico para la empresa, puesto que estaba justamente planificándose dentro de toda la gran parada de planta que íbamos a realizar, la próxima aproximadamente 14 días de una ventana, ¿no? ¿En qué consistía? Pues consistía en intervenir el reemplazo de dos equipos estratégicos, en realidad un equipo estratégico, pero que venía vinculado a un sistema de chancado, ¿no? Y ese equipo justamente era este chancador primario, ¿no? Acá tenemos una chancadora de quijada, teníamos que reemplazarla, y teníamos que también, de alguna forma, realizar la ingeniería y adecuación y mejora de esta tolva de grueso, ¿no? Que era de alguna forma el embudo donde se recibía el mineral que venía procedente de la explotación, ¿no? Y que luego pasaba por un grizzly o una zaranda, y luego esto pasaba a un proceso de un chancado mayor, ¿no? Chancadora primaria. Entonces, algo que aparentemente podría ser sencillo, involucra un reto porque implica conocer mucho del proceso de chancado, involucra conocer los tiempos que vamos a estar trabajando, además las interferencias que vamos a tener que tener, no solamente dentro del proyecto, sino también con todos los terceros que van a trabajar dentro del área de influencia, ¿no? Y mucho pesa la seguridad. La seguridad justamente como parte es un objetivo dentro de esta implementación VDC. Bien, dentro también de esta introducción quería mencionarles la importancia de saber cuál es nuestra área de influencia, cuál es nuestra forma de trabajo cada vez que implementamos VDC. Y acá les traigo una curva que quizás la han visto muchísimo, que es la curva de esfuerzo de tiempo de Patrick McLemy, ¿no? Solamente para mencionarles que esta área es la que quizás como propietario yo he tenido la oportunidad de influenciar, ¿no? Ya que desde las etapas tempranas he podido ver la parte de diseño y luego ver cómo en la etapa de construcción o la etapa ya de realización de esta parada de planta pues se pudo llevar a cabo. Bien, el framework que voy a referido aquí, creo que ya la conocen, lo voy a pasar rápidamente, ¿no? Solamente recalcarles acá la necesidad de tener siempre esta articulación, ¿no? Objetivo del cliente, proyecto y las tres patitas de la mesa, ICE, BIM y PPM. Obviamente amarrado, vinculado con métricas y factores controlables que van a tener cierto nivel de consistencia para conseguir el objetivo final. El resumen de la implementación consiste en llevar a cabo una estrategia o consistió en llevar a cabo una estrategia para cumplir el plazo del proyecto dentro de esta ventana de los 14 días de parada de planta, y además garantizar una satisfacción del usuario para la operación y mantenimiento. Como se ve aquí en la parte derecha, importante es entender el objetivo del owner o el cliente, en este caso nuestro. La misión era poder garantizar el sostenimiento o sostenibilidad de las operaciones de la planta para poder manejar esta reducción del tiempo estancado con este nuevo equipo y ampliar un 20% de su capacidad de procesamiento. Pues esto que nos lleva a tener que licitar o desarrollar una ingeniería, que luego se va a hacer implementada en la etapa de construcción, para que éste sea lo más confiable posible, segura y operable. Entonces, desarrollamos sesiones SAIS como parte de ello, involucramos actores claves, nos orientamos a la constructabilidad y mantenidad desde la etapa temprana del proyecto, realizamos una planificación 4D para simular el proceso constructivo más idóneo, además obviamente de identificar incompatibilidades e interferencias, y nos permitimos realizar una mejora en la gestión de la producción y la planificación del proyecto, pensando en todo el tema de seguridad y en todo el tema de construcción. Acá ustedes pueden ver el framework, algunas métricas y factores controlables que pude, en mi experiencia, poder implementar, ¿no? Aquí tengamos en cuenta que podemos nosotros empezar con un backlog de estas métricas, pero en la medida que tú vas implementando, vas a poder mejorar. De hecho, hay algunas que yo fui reemplazando, otras en mi reporte 2, 3, y otras que fui quitando, otras que fui añadiendo, otras que fui fusionando, ¿no? Esto es importante darse cuenta, porque ningún plan es estático, ¿no? Todo es dinámico, y todo va a estar susceptible siempre a la mejora continua. Siempre con esta estrategia de querer, de buscar justamente los objetivos del proyecto y los objetivos del cliente. En este caso, 0 accidentes y asegurar el plazo dentro de la ventana de la parada de planta. Otro punto que traigo acá a compartirles es el poder llevarlo esto como si fuese un proyecto, ¿no? En Compañía de Minas Buenaventura era la primera vez que se hablaba un poquito de esto, hace ya 2 años, hoy en día es un poco más conocido. Sin embargo, era necesario trabajar mucho la parte de capacitación, ¿no? Ir de a poco, ¿no? Justamente dar a conocer a través de talleres la necesidad de por qué trabajar con VDC y por qué trabajar con modelos. En el mundo de la minería le conocen como maquetas, ¿no? Bien, algunos resultados que quería rápidamente compartirles es que pudimos darnos cuenta la necesidad de desarrollar algunas ingenierías complementarias de componentes adicionales para agregarle valor al proyecto, ¿no? Por ejemplo, necesitábamos tener un puente grúa que permita mejorar el mantenimiento de este equipo y no poder, digamos, hacer un reemplazo a través de un izaje de grúas solamente cuando tengamos que hacer un reemplazo del equipo, sino de una forma periódica y constante. Y vamos a tener que instalar un sistema de rompebancos en la parte superior para mejorar la granulometría del material que iba a ingresar en la zona de tolveo. Se hizo una propuesta de instalar un sistema de cámaras para mejorar el tiempo de respuesta de los eventos en la planta. Esta zona era con bastante polución, ¿no? Entonces se implementó un sistema de extracción de polvo en la parte inferior aguas abajo y un sistema de iluminación para evitar cualquier accidente y o paralización de procesos durante ya el proceso de la operación. Entonces todo eso permitió mejorar la operatividad y riesgos, ¿no? Esto lo estuvimos manejando desde la etapa de ingeniería básica, para mencionarlo, esto es básico y detalle, y justamente empezamos a trabajar con los modelos BIM apenas teniendo nivel de desarrollo de lot 100, lot 100, 200, y luego lo fuimos mejorando. Como yo siempre lo digo también, le digo a mis alumnos, lo perfecto es enemigo de lo bueno, así que hay que empezar a tener las famosas ganancias tempranas, o los quick wins. Y una forma de mostrar eso y estos beneficios que uno va teniendo con todas las personas que uno involucra en las sesiones SAIS, ¿no? Lo va haciendo de a poco. Medir también, ¿no? ¿Qué tan efectivos estamos siendo? ¿Conseguimos nuestros objetivos? ¿No los conseguimos? Dentro de los resultados, pues también empezamos a trabajar un requerimiento BIM, el famoso EIR, ya para empezar a hacer solicitudes de planes de ejecución BIM en la etapa de propuestas. Esto nos permitió, a partir ya desde el año pasado, a buscar tener, que en el proceso de licitación, tener claro nuestros usos, nuestros objetivos, ¿no? Como clientes tenemos esa gran responsabilidad y tenemos que marcar las pautas a las empresas que desarrollarán la ingeniería o que desarrollarán la construcción. El entorno común de datos también es algo que lo discutimos en esa etapa previa. Los factores positivos que les mencionaba y los factores negativos, la mejora continua tiene que ser clave en todo esto, ¿no? Y al margen de ello, pues es importante que podamos entender que hay otro tipo de tecnología disponible, y a nosotros nos pasó, ¿no? Porque las personas del área de operaciones, por ejemplo, manejaban mucho, o tenemos instalados algunas cámaras donde uno puede ver, digamos, cómo está descargándose el mineral y cómo estos llegan al sistema de tolveo para luego llegar al chancador. Entonces, llegar a hacer esa trazabilidad de esa información a través de las cámaras y despertar la curiosidad del personal de planta, que es personal netamente operativo y que no necesariamente pues, es ingeniero civil como muchos de nosotros, pueden ser ingenieros mecánicos, ingenieros metalúrgicos, ingenieros químicos, pero sí tienen mucha responsabilidad en los resultados de cómo se van moviendo sus niveles de recuperación de concentrados, sus desperdicios, ¿no? Sus niveles de agua, niveles de aire. Entonces ellos se dieron cuenta justamente que podían ir encontrando otros beneficios más allá de trabajar con modelos, ¿no? Cómo poder integrar esto, por ejemplo, con el análisis de producción del mineral, ¿no? Y cómo podemos optimizarlo esto en la medida en la que podamos también reducir la granulometría desde justamente desde las zonas de explotación del mineral, ¿no? Lo que dentro de la minería le conocen como mining, ¿no? Y bien, en la parte de resultados también me interesa mucho comentarles esto, el diamante de emoción del usuario. Nosotros desde un principio crecimos con un sentido de competencias. Se buscó esta colaboración en todas las personas que participaron durante esta experiencia de casi año y medio de implementación. Y valgan verdades, muchas de las personas cuando les hicimos esta encuesta de alguna forma cualitativa en Menti, nos expresaron su gratitud porque aprendieron algo más y todos se fueron de alguna forma encantadas, ¿no? Encantadas, siempre con los ánimos de seguir mejorando, ¿no? De hecho, hemos trabajado esto no solo en la etapa de ingeniería, hemos trabajado en la etapa propia de construcción, en una siguiente parada a fines del 2020, inicios del 2021. Hemos también, ahora trabajando, estamos implementando en un proyecto de un relleno hidráulico, también es un proyecto underground y open pit, ¿no? Con retos distintos porque las personas son distintas, ¿no? Y esto involucra también que poco a poco ya vayamos mejorando. Y bueno, conclusiones, esto me gusta compartirlos también porque creo que VDC te permite tener una máxima colaboración al personal clave. Llámese proyectos desde el cliente o proyectos del contratista, un usuario, ¿no? Importante que también entienda cuál es el producto que va a recibir, ¿no? Como alguna vez yo lo conversaba también con un superintendente de proyectos y le mencionábamos al superintendente de planta y de mantenimiento, ¿no? Le decíamos, necesitamos tu colaboración en alguna de estas sesiones hay porque vamos a diseñar un producto a tu medida, como el sastre, ¿no? El sastre que te diseña, te hace tus mediciones y al final te da un terno que justamente calza con tu biotipo, ¿no? Con tus medidas. Lo entendió de esa forma perfectamente. El involucramiento con el usuario, como les mencionaba, desde etapas tempranas. Tuvimos la oportunidad de hacerlo desde etapa de ingeniería básica y de detalle con excelentes resultados en la etapa ya de construcción. La maximización del uso de modelo BIM a lo largo de todo el ciclo de vida, el análisis de constructabilidad y mantenibilidad algo que muy pocas veces se realiza o no se realiza de una forma correcta, usando VDC, lo potencia enormemente. Bueno, en otro momento les haré un poquito más del detalle de esto. Y los procesos de gestión de proyectos que tienen un enfoque holístico e integrador, ¿no? A nivel de procesos, personas y herramientas. Bien, muchísimas gracias por haberme escuchado. Trataba de resumir lo mucho que realmente se aprende dentro de una implementación. Quienes han tenido la oportunidad de hacerlo seguramente me entienden, pero estos han sido los principales, digamos, puntos que quisiera compartirlos con todos ustedes y con la audiencia. Muchísimas gracias y nos vemos en otra oportunidad. Hasta luego.
Esperamos que hayan disfrutado de la presentación del ingeniero Juan Carlos Maita. Estaremos compartiendo su correo electrónico para que le hagan llegar cualquier pregunta o comentario. Ahora, la segunda certificada es Steffi Guaranga. Ella es ingeniera de oficina técnica en la empresa BAU, gerenciamiento y supervisión de proyectos.
Buenas noches, muchas gracias por estar viendo esta grabación. Mi nombre es Steffi Guaranga, actualmente me desempeño como ingeniera de oficina técnica en la empresa BAU Gerenciamiento y Supervisión de Proyectos. En esta oportunidad compartiré la implementación VDC que el equipo en el que participé y yo desarrollamos hace unos meses, el año pasado. Entonces procederé a compartir mi pantalla. Muy bien. Este fue el proyecto de construcción, fue un proyecto de inversión pública del Centro de Salud en la ciudad de Loroya. El contratista fue la empresa Avanzada Tecnología y Servicios SAC y mi rol fue el de ingeniería de producción. Este es el marco de implementación VDC que desarrollamos. Como pueden ver, el objetivo del cliente fue el de cumplir con los hitos contractuales. Para marzo del 2022, esto significaba terminar el casco estructural y tener un avance considerable en la arquitectura de las instalaciones. El objetivo del proyecto buscaba cumplir con los hitos contractuales, pero con 2.5 semanas de adelanto. Es decir, terminar el casco estructural y tener el mismo avance para mitad de febrero. El componente ICE fue empleado para promover la colaboración entre el cliente, el contratista y la supervisión. El componente BIM fue empleado para estimar metrados y como apoyo visual para la planificación y gestión de la producción en obra. Y finalmente el componente PPM fue empleado para realizar el mapeo de procesos colaborativo. Entonces, este es el caso de estudio que presentaré hoy, que corresponde a la producción de concreto en obra. Como pueden ver, el elemento estructural en participación para este caso fue el de las cimentaciones. Esto representaba un volumen de 524 metros cúbicos de concreto. El equipo en planta con el que disponíamos fue una planta de concreto manual con botones y manivales que necesitaban ser operados en tiempo real por una persona para producir concreto, una bomba y una pluma de concreto para colocar esto en las cimentaciones. Entonces, sin VDC, producimos concreto para probar. Esto nos tomó 49 minutos producir 6 metros cúbicos. El contrato nos estipulaba que toda esta cimentación de 524 metros cúbicos nos requería un tiempo de 34 días, con un empleo de una cuadrilla de 5 personas y con el involucramiento de 4 personas del staff técnico, ¿no? Esta es la imagen del inicio. Gracias al VDC, esta imagen cambió. Producir la misma cantidad de metros cúbicos de concreto nos tomó 30 minutos. La partida duró en total 7 días, 4 días encofrando y 3 días vaciando 524 metros cúbicos de concreto, con una cuadrilla de 9 personas y con 8 involucrados, casi el doble de involucrados. Todo esto implementando 22 propuestas de mejora. Entonces esa es la metodología que empleamos, fue escalonada. Al inicio, ahí me encuentro yo, desarrollé un mapeo de procesos inicial que compartí con mis compañeros en conjunto. Seguimos editando este mapeo de procesos para entender en conjunto todos qué es lo que íbamos a hacer. Seguimos invitando a más personas, ya que era necesaria la participación. Estaban directamente o indirectamente involucrados. En conjunto identificamos y analizamos las restricciones. Todo esto estaba aún en papel. Aún faltaba la validación. Y esto fue el siguiente paso, validar toda la secuencia de procesos que pensábamos que ocurriría en la producción real de concreto. Para ello, vaciamos un pequeño muro de contención, lo cual requería producir concreto, ¿no? Y eso nos permitió tener ya números y ver quiénes eran los ejecutores y constructores directos, que son los operarios de la maquinaria y de la planta, ¿no? Gracias a este entendimiento general y total, nosotros pudimos proponer ya las soluciones de mejora. Este fue el mapeo de procesos inicial. Como pueden ver, separé cada fila por un equipo de trabajo y empecé a colocar inventarios representados por triangulitos rojos donde yo estimé que habrían tiempos de espera, tiempos muertos. Esto fue compartido con el residente, el jefe de campo, el ingeniero de planta, el personal directo a la producción de concreto, ¿no? Gracias a su experiencia y en conjunto vimos que habían partidas, habían procesos que ya conocíamos y que no iban a representar un cuello de botella. Por ejemplo, la colocación de concreto, realizar los ensayos de calidad, y empezamos a colocar nuestra atención y enfoque en donde sí había desconocimiento, donde sí habría un cuello de botella, ¿no? Que es lo que vemos enmarcado en el cuadrado rojo. Todo esto lo trasladamos a un diagrama CIPOC, que esta es una herramienta de Lean Construction que nos permite identificar el proceso, los involucrados y lo que fluye. Entonces, esto se empieza a leer de dentro para afuera. Al inicio nos hacemos la pregunta, ¿hay vaciado o no? ¿Qué necesitamos? ¿Y cuál es el objetivo final? Bueno, en este caso era producir concreto. Este diagrama nos permite colocar en los laterales qué es lo que fluye al inicio y al final. En este caso en particular fluye información, la cantidad de metros cúbicos, fluye el dato de humedad de los agregados, información, y también fluyen materiales que son los agregados, ¿no? El cemento y el agua. Y lo que sale es algo físico, los metros cúbicos de concreto. Y esto también, este gráfico nos permite asociarlo a los involucrados directos, ¿no? ¿Quién es responsable de brindarme estos inputs? Y finalmente, ¿quiénes son nuestros clientes internos? ¿Quiénes reciben lo que sale de esta caja transformadora, que es un proceso de construcción? Entonces, gracias a esto vimos que lo que fluye es información y fluyen materiales. Gracias a que supimos quiénes son los responsables, los invitamos también para que ellos participen. Entonces aquí ya nuestro mapeo de procesos cambió y el cuello de botella fue identificado ya con claridad, que estimamos era el mezclado de los materiales en el mixer, ¿no? Ya pusimos nombres a los posibles esperas, por ejemplo, esperar al laboratorio, esperar al operario de la maquinaria, esperar a la llegada de materiales. Todo esto lo tuvimos que validar en campo. Como mencioné, usamos los procesos para evaluar nuestra propuesta teórica en la producción de concreto de un pequeño tramo de un muro de contención. Ahí realicé una carta balance empezando a medir la duración de cada uno de estos procesos. El tiempo total que nos tomó fue de 49 minutos el producir 6 metros cúbicos de concreto. Y no solo eso, sino que sabíamos la velocidad de cada proceso. Y sabíamos el tiempo de espera casi exacto de los inventarios, los triángulos rojos. Y obviamente el cuello de botella pasó de solamente la mezcla en el mixer a contemplar también el carillo a la planta. Entonces, involucramos a más personas ya con estos datos numéricos y empezamos a proponer soluciones para mejorar. Al inicio es importante ver cómo mejoramos en el flujo. Para producir este concreto necesitamos que cada una de estas cajas vayan a su velocidad. Por ejemplo, solicitamos la presencia de más operarios, de más vigías. También solicitamos calibrar de manera anticipada los equipos para no tener que parar la planta para calibrarlos. Proponer planes de contingencia en caso el cargador se quede sin combustible, en caso la planta se atore, o en caso suceda algo que corte el flujo. Y luego mejoramos en los procesos, que son, bueno, estos están relacionados a las estrellas que vemos en pantalla, ¿no? Por ejemplo, el carillo de piedra y arena, que inicialmente nos tomaba 20 minutos, recibió 3 propuestas de solución, de optimización, como por ejemplo aumentar un vigía, para que el operario de telehandler lo haga más rápido y más seguro. Empezar de manera anticipada con los procesos. Si el vacío era a las 8, empezamos a trabajar a las 5 de la mañana recibiendo. Y revisar estrictamente que la cantidad de volquetes llegue a obra y que estos estén llenos, ¿no? Para contar con el material máximo posible en campo. Entonces así fue como las estrellas representan las propuestas de solución localizadas en los procesos y obviamente hay una reducción de tiempo asociada a estas mejoras. Entonces, de 49 minutos que nos tomó hacer los primeros 6 metros cúbicos de concreto, gracias con estas soluciones que realizamos todos en conjunto, nos tomó 30 minutos. Como conclusiones, comparto que esta experiencia me permitió comprender que el desarrollo de un mapeo de procesos es dinámico, tiene que ser colaborativo, y este es el ejemplo claro, ¿no? Si yo me hubiese guardado la información, probablemente hubiese tenido cero propuestas de mejora, pero gracias al equipo de trabajo y a su involucramiento tuvimos 22 propuestas. El mapeo de procesos en el cual tenemos que enfocarnos tiene que estar necesariamente conectado a los objetivos del proyecto y del cliente para que sean incidentes. Asimismo, es importante identificar lo que fluye: información, personas, materiales, procesos, identificar también quiénes son los responsables de cada proceso, identificar los inventarios, el cuello de botella y cuantificarlos también es importante en este análisis. Y finalmente el componente BIM fue empleado como apoyo visual, pero nos permitió tener un metrado casi exacto. No invertimos mucho en el modelo BIM en esta etapa, como pueden ver, pero nos dio grandes resultados. Muchas gracias por su atención. Ahí les presento al equipo en campo y una imagen de uno de los días de vaciado de concreto. Gracias, les deseo mucha dicha y fortuna en su ruta VDC. Que sigan disfrutando del Congreso. Hasta luego.
Esperamos que hayan disfrutado la presentación de Steffi Guaranga. Estaremos compartiendo también por el chat su correo electrónico para que le hagan llegar cualquier consulta o comentario que tengan.
Okay. Antes de finalizar, invitamos al doctor Alexandra Almeida, director del Instituto de Investigación Científica de la Universidad de Lima, coordinador del Programa Internacional VDC y del Congreso Internacional VDC, para que diga unas palabras de cierre de esta tercera edición del Congreso Internacional VDC.
Muchas gracias, Diana. Muchas gracias, Leopoldo. Muy bien, señores. Entonces, llegamos al final de nuestro tercer Congreso Internacional VDC, organizado por la Universidad de Lima en colaboración con el SAIF y el Stanford Center for Professional Development. Esperamos haber cumplido nuestro objetivo de promover conocimiento, teniendo la metodología VDC como motor de cambio en la gestión de proyectos dentro de los entornos híbridos hacia la mejora y modernización de nuestra industria. Me gustaría agradecer a todos los asistentes que nos acompañaron a lo largo de los 3 días del Congreso, así como a los moderadores del evento y especialmente a los expositores invitados: Martin Fischer, Nora Dayton, Laura Coscuela, Tulika Majumdar, Omar Alfaro, Raúl Isragiri, Roberto Arbulu, Ashwin Agarwal, Letícia Zanotti, Johnny Reimstad, Leonardo Rushmoller, Luciana Birdi e Enrico Aleixo. E também a nossos certificados VDC Juan Carlos Maita, Steffi Aranga, Mônica Vergara, Alejandro Palpan, Mário Mendonça, José Vidal e Álvaro Bassan. Me gostaria de comentar também que continuaremos compartilhando conhecimento com vocês através de nossos futuros eventos, canais de comunicação e principalmente, senhores, através do programa VDC, el cual empezará muy pronto, el lunes 22 del presente mes. Señores, las inscripciones aún están abiertas para esta 4ª edición del programa VDC, pero con vacantes limitadas. Entonces, están todos invitados. Espero que se animen a ser parte de este gran cambio. Muchas gracias nuevamente a todos y buenas noches con todos. Muchas gracias.
Agradezco su participación a lo largo de este evento. Damos por finalizado el tercer Congreso Internacional VDC. Los certificados estarán siendo emitidos aproximadamente a partir de inicios de septiembre. Estaremos compartiendo más novedades de ello en nuestras redes sociales. Recordarles asimismo que los certificados serán enviados a los correos con los que se inscribieron y las ponencias serán subidas a la página de YouTube de la Universidad de Lima. Los invitamos a estar atentos a nuestras redes sociales, más novedades y preguntas por medio de nuestras redes. Muchas gracias, buenas noches.